What is the variance?
The variance is the average of the squares of a set's deviations. It is used to characterize the spread among the measures of a given population. First, calculate the mean of the scores, then measure the amount that each score deviates from the mean. Finally, square that deviation, in other words, multiply it by itself. Add all of them together, then divide by the total number of scores.
Who built the first mechanical binary computer?
German civil engineer Konrad Zuse, 1910 to 1995, built the Z1, often thought of as the first mechanical binary computer in his parents' living room around 1938. His goal was to build a machine that would perform the lengthy and tedious calculations needed to design building structures. His computer's design stored intermediate results in its memory and performed sequences of arithmetic operations that he programmed on punched paper tape. He initially used old movie film. This machine led to the Z3 in 1941. Considered by some to be the first large-scale, fully functional automatic digital computer, the computer used a binary number system.
Did any cultures use more than one base number in their numbering system?
Certain cultures may have used a particular base as their dominant numbering system, such as the Sumerians' base 60, but that doesn't mean they didn't use other base numbers. For example, the Sumerians, Assyrians, and Babylonians used base 12, mostly for use in their measurements. In addition, the Mesopotamian day was broken into 12 equal parts. They also divided the circle, ecliptic, and zodiac into 12 sections of 30 degrees each.
What is non-Euclidean geometry?
Non-Euclidean geometry is a branch of geometry that deals with Euclid's fifth postulate, the parallel postulate that only one line is parallel to a given line through a given external point. This postulate is replaced by one of two alternative postulates. The results of these two alternative types of non-Euclidean geometry are similar to those in Euclidean geometry, except for those propositions involving explicit or implicit parallel lines. For more information about non-Euclidean geometry, see History of Mathematics.
What are vertical asymptotes in association with limits?
Using the example above, as x gets closer to 3, the points on the graph get closer to the vertical line x equals 3. Seen as a dashed line on the graph on p. 218, this line is called a vertical asymptote. The above chart shows 4 of the vertical asymptotes for the given function f, x, and their notations.
What are arithmetic series and sequences?
An arithmetic series, also called arithmetic progression, is one of the simpler types of series in mathematics. In such a series, each new term is the previous number plus a given number. It is usually seen in the form of a plus a and d, plus a plus 2d, plus a plus 3d, plus a plus and 1d. An example of an arithmetic series would be 2 plus 6 plus 10 plus 14 plus, and so on, in which d is equal to 4. The initial term is the first one in the series. The difference between each term, d, or 4 in this case, is called the common difference. An arithmetic sequence is usually in the form of a and d, a plus 2d, a plus 3d, and so on, in which a is the first term and d is the constant difference between the two successive terms throughout. An example of an arithmetic sequence is 1, 4, 7, 10, 13, in which the difference is always a constant of 3. The notation for arithmetic sequences is n plus 1 equals n plus d.
What are implicit and explicit differential equations?
As seen above, an ordinary differential equation is one involving x, y, y, and so on. Now add the idea that the order of the highest derivative is n. Thus, if a differential equation of order n has the form f, x, y, n, equals 0, then it is called an implicit differential equation. If it is of the form f, x, y, and 1, equals y, n, it is called an explicit differential equation.
What is pi and why is it important?
Pi is the ratio of the circumference to the diameter of a circle.
What science fields use an abundance of mathematics?
The sciences that are heavy users of mathematics are the so-called physical sciences, including physics, chemistry, geology, and astronomy. These scientific fields are often contrasted with the natural or biological sciences. The physical sciences analyze the nature and properties of energy and non-living matter, and they often need the help of mathematics to determine the complex relationships between their interactions.
What is a Stomachion?
A Stomachion is a dissection puzzle similar to a tangram. It uses 14 pieces in the puzzle, each of varying polygonal shapes and arranged into a 12 by 12 square grid. Each of the pieces has an area that is an integral fraction, for example, 24, 12, 9, 6, or 3, of the total area of the square, which is 144 units. The object of a stomachion is to arrange the pieces into interesting and often recognizable shapes, such as people, animals, and objects. This puzzle was also an ancient game known to the Greek mathematician Archimedes, c. 287 to 212 BCE, and thus is also called the loculus of Archimedes, Archimedes' box. It is doubtful Archimedes invented the puzzle, but he did explore its geometric aspects. It also now appears that in contemplating the different solutions to this puzzle, Archimedes actually was anticipating the branch of mathematics we now call combinatorics.
What does the term bisect mean?
The term bisect is important in geometry. It means to cut into two or divide into half, mainly lines, or two-dimensional figures, and angles. To compare, a bisected line segment means finding the plane line, or point that is the midpoint of the line segment. This is also called a segment bisector. An angle bisector is a ray in the interior of an angle that forms two equal angles. First, locate the point on each ray that is equally distant from the vertex. Then draw a third point equally distant from each of the first two rays. A line that extends through the third point and the vertex is the angle bisector. To draw a bisector, follow the sequence, as per the illustration above. First, draw an angle. Then draw an arc centered at the vertex, end point, in which B and C are the intersections of the arc and angle lines at equal distances from the vertex. Next, draw an arc centered at B and one centered at C, both with the same radii inside the angle. Finally, extend a line from the vertex to the point D where the arcs of B and C intersect, making AD the bisector of the angle at A.
What is the Dewey Decimal System?
The Dewey Decimal System of classification is a numerical method libraries used to classify nonfiction publications into groups based on subject. It was invented by American librarian Melville Lewis Kossuth Dewey, 1851 to 1931, as a system for small libraries. The subject of a book is classified by a three-digit numeral that represents 10 classes of subjects, 000-999. In order, these are generalities, philosophy and psychology, religion, social science, language, natural science and mathematics, technology, applied sciences, arts, literature, and geography and history. For example, the handy math answer book would be found in the Dewey Decimal System under the 500s for natural science and mathematics. A Dewey Decimal Classification number is followed by the Cutter number, or Cutter. This method was invented by Charles M. I. Cutter, 1837 to 1903, and is an alphanumeric way to represent words or names by using one or more letters followed by one or more Arabic numerals used decimally. Both systems, the Dewey Decimal System and Cutter, are together called the call numbers. A way of locating every book in a library.
Why are arcs and angles important to circles?
Everything starts with the angle whose vertex is at the center of the circle. Logically called the central angle of a circle. All the central angles of a circle add up to 360 degrees. Every central angle cuts the circle into two arcs, the minor arc, always less than 180 degrees, and the major arc, always more than 180 degrees. Thus, the measure of the minor arc is actually the measurement of the central angle, while the measurement of the major arc is 360 degrees minus the measure of the central angle. An arc length is the distance between an arc's endpoints along the path of the circle. Congruent arcs are arcs with the same measurements. When the diameter of a circle separates the circle into two congruent arcs, it is called a semicircle.
What contributions did David Hilbert make to mathematics?
German mathematician David Hilbert, 1862 to 1943, contributed a great deal to mathematical logic, as well as mathematics in general. In 1890, his proof of the theorem of invariance replaced earlier work on the subject and paved the way for modern algebraic geometry. By 1897, his algebraic number theory led to many developments in that field. His contributions also included discoveries in number theory, mathematical logic, differential equations, multivariable calculus, Euclidean geometry, and even mathematical, theoretical, physics. Hilbert is most well known for presenting Hilbert's problems, which originally were a set of 23 unsolved mathematical problems that he hoped would eventually lead to many more disciplines within the field of mathematics. His idea worked. As mathematicians attempted to solve the problems, their efforts led to mathematical discoveries in the 20th century. Although a number of the problems have yet to be solved. For more information about Hilbert, see History of Mathematics.
How else is mathematics used in physics?
There are hundreds of other applications of mathematics in physics.
What does continuous and discontinuous mean in calculus?
When talking about polynomial functions, we know that a polynomial function p x satisfies the limit function, lim p, x, equals p, a, in which a represents all real numbers. This is called continuity. But if f, x, is a function on an interval around a, then f, x, is continuous at a IFF, see above for the definition of IFF. Lim f, x, equals f, a, if it is not, then f, x, is called discontinuous at a.
How did the slide rule evolve?
In 1620 English astronomer Edmund Gundar, 1581–1626, was responsible for constructing a scale rule that could be used to multiply. He divided his scale according to Napier's principle of logarithms, meaning that multiplication could be done by measuring and adding lengths on the scale. It is also often considered the first analog computer. But there is disagreement as to the true inventor of the slide rule. Many historians give the credit to English Reverend William Uhtred, c. 1574–1660, who improved upon Gundar's idea. About 1630, although that date is highly debated, Uhtred placed two of Gundar's scales directly opposite each other and demonstrated that one could do calculations by simply sliding them back and forth.
What is abstract algebra?
Abstract algebra is a collection of mathematical topics that deal with algebraic structures rather than the usual number systems. These structures include groups, rings, and fields. Branches of these topics include commutative and homological algebras. In addition, linear algebra and even elementary number theory, see Math Basics, are often included under abstract algebra.
What is a subset and proper subset in set theory?
Simply put, a subset is a portion of a set. If set B is a subset of set A, then all elements of set B are also elements in set A. If A and B are equal, then both sets are subsets of themselves. The empty set is also considered a subset of every other set. A proper subset is a subset other than the set itself.
What was one of the first devices used to measure time?
One of the first devices smaller than the obelisks mentioned above to measure time was a crude sundial. By about 1500 BCE, the true, small sundial, or shadow clock, was developed in Egypt. It was divided into 10 parts, with 2 twilight hours marked. But it could only tell time for half a day, afternoon. the sundial had to be turned 180 degrees to measure the afternoon hours. More refinements of measuring time occurred later. In order to correct for the sun's changing path over the sky throughout the year, the gnomon or object that creates the shadow on the sundial had to be set at the correct angle, what we call latitude. Eventually, the sundial was perfected. Multiple designs were used. For example, shortly before 27 BCE, the Roman architect Marcus Vitruvius Polios, c. 90 to 20 BCE, De Architectura described 13 different designs of sundials.
What is Euclidean space?
Euclidean, also seen as Euclidean, space is often called Cartesian space, or more simply, n-space. It is made up of n dimensions and is a set of points, with each point represented by a coordinate of n components. Space with 2 to 3 dimensions and that does not use Einstein's and others' ideas of relativistic physics are considered Euclidean space. In Euclidean space, distance is defined by certain rules. The distance between 2 points is positive. Unless they are the same points, the distance from points A to B.
What does an equal sign represent?
In standard arithmetic terms, the equal sign, smiley face, is a symbol that represents two amounts with the same value. For example, 7 equals 7, or 3 plus 4 equals 7. When something is not equal, the sign is asterisk. As in 2 asterisk 3 or 3 plus 7 asterisk 12. In a line of computer code, the equal sign can mean something much different. For example, for codes used under certain conditions, such as a JavaScript reading computer, a single equal sign in a line of script means is. There is even a double equal sign, equals, smiley face, that means is equal to. An important difference when writing code for the computer. In addition, and confusing as it may seem, the computer codes for not equal are different, and include equals and slash equals.
How is the magnitude of a vector determined?
The magnitude of a vector is equivalent to the length of a vector. Placing a pair of vertical lines, similar to the absolute value symbol, around a vector implies the magnitude of the vector. For example, if the variable v is used to represent a vector, then the expression v indicates the magnitude of the vector.
What is sociology?
Sociology is the study and classification of human societies. It delves into the relationships among peoples mostly within, but also outside, each culture. Sociology studies are based on the idea that behavior of peoples is influenced by social, political, occupational, and intellectual groupings. It is also based on the immediate and particular settings in which individuals reside.
How do scientists use mean sea level in connection with global climate change?
Many scientists are interested in the long-term mean sea level change, especially in connection with global climate change. By taking such long-term measurements, these scientists are hoping to confirm the predictions of several climate models, including the idea that global warming is a result of the greenhouse gases from either human or natural sources. There are two major ways to determine such sea level variations. The first estimates sea level changes using tide gauge measurements, mathematically averaging the numbers. Graphs of the most recent estimates using this method show a 0.669 to 0.960 inch, 1.7 to 2.44 millimeter, rise in sea level per year. The second method uses Global Positioning System, GPS, devices and satellite altimeter measurements, both of which accurately pinpoint global ocean heights quickly and more efficiently. For example, from 1994 to 2004, scientists mathematically constructed graphs from satellite altimeter measurements, showing that the global mean sea levels have risen anywhere between 1.10 and 1.18 inches, 2.8 and 3.0 millimeters. No matter what the method, scientists do know the global mean sea levels are slowly rising. Many believe that about 1/4 of the rise is caused by thermal expansion as the oceans warm, and another 1/4 by small glaciers melting around the world. Some rise may also be caused by such human activities as burning trees, pumping groundwater, and draining wetlands. Currently, scientists are not quite certain about the true rate of sea level rise, mainly because of the intensity of working on the data. Ocean tide gauge records must be averaged over many decades, and corrected for variable ocean dynamics and distortions of Earth's crust.
How do you expand logarithms?
Like an algebraic expression, it is possible to expand logarithms, which is a way of picking apart an expression. The following lists two examples of expanding a logarithmic expression. To expand log 2, 3x, equals log 2, 3, plus log 2, x, to expand log 2, 12/x, equals log 2, 12, log 2, x.
Did the Babylonians finally use a symbol to indicate an empty space in their numbers?
Yes, but it took centuries. In the meantime, scribes would not use a symbol representing an empty space in a text, but would use phrases such as "the grain is finished" at the end of a computation that indicated a zero. Apparently, the Babylonians did comprehend the concepts of void and nothing, but they did not consider them to be synonymous. Around 400 BCE, the Babylonians began to record an empty space in their numbers, which were still represented in cuneiform. Interestingly, they did not seem to view this space as a number what we would call zero today, but merely as a placeholder.
How is air temperature measured?
Simply put, there are two ways to look at air temperature: on the microscale. It is the small-scale measure of gas molecules' average kinetic energy. On a larger scale, it is the action of the atmospheric gases as a whole. In physics, an entire branch is devoted to objects' temperatures and the transfer of heat between objects of differing temperatures. Called thermodynamics, it is a study that entails a great deal of mathematical knowledge. No matter what the type of temperature discussed. The most common apparatus for measurement is the thermometer. The most familiar thermometers are thin, long, closed glass tubes containing some type of liquid, most often alcohol or mercury. When the temperature increases or the air around the tube heats up, it causes the liquid to expand, moving it up the tube. Air temperature measurements are most commonly read in centigrade or Fahrenheit. For more about centigrade, Celsius and Fahrenheit, see Mathematics Throughout History.
How did Gottfried Wilhelm von Leibniz advance calculating devices?
German mathematician and philosopher Gottfried Wilhelm von Leibniz, 1646-1716. Not only described the binary number system, a central concept of all modern computers, but also co-invented differential calculus and designed a machine that would perform the four basic arithmetic functions. By 1674 he had completed his design and commissioned the building of the Leibniz step drum, or the step reckoner, as he called his machine. The device used a special type of gear named the Leibniz wheel, or step drum. A cylinder with 9 bar-shaped teeth along a length parallel to the cylinder's axis. As the cylinder was rotated with a crank, a 10-toothed wheel would rotate from 0 to 9 positions, depending on its position from the drum. The movements of the various mechanisms would be translated into multiplication or division, depending on what direction the step drum was rotated. Although there were apparently only 2 prototypes of the device, both still exist. Leibniz's design along with Pascal's were the basis for most mechanical calculators in the 18th century. As with most such machines that could not be mass-produced, much less understood by The masses they were more curiosities for display than machines put to actual use.
What is the scale of a map?
Most travel, street, or highway maps show a measurement scale, usually in terms of miles and kilometers. To determine a straight line, horizontal, distance on a map. Take a piece of paper and mark the origin and destination as tick marks on the paper. Then measure the distance between the tick marks based on the map scale to find the distance in miles or kilometers. Topological maps also have scales, but in this case the scale is a ratio representing the measure on a map to some number of the actual units of measure on the Earth's surface. For example, a map with a scale of 1:25,000 means that 1 inch on the map is equal to 25,000 inches on the ground. Because both numbers have the same units, it can also be interpreted as any unit measure. For example, the same map could also be interpreted as 1 centimeter equals 25,000 centimeters on the ground. Or 1 meter equals 25,000 meters, and so on. For those who prefer to measure in miles and kilometers. Most topographic maps also offer a graphic scale in the legend. For more about scales, see Math in Engineering.
What is Pascal's triangle?
Pascal's triangle, as the name implies, is a collection of numbers in the shape of a triangle. Each number in the triangle is the sum of the two directly above. For example, in the accompanying illustration, the 6 on line 5 is the sum of the pair of 3's above. The next line is 1, 10, 1 plus 9, 45, 9 plus 36, 120, 36 plus 84, and so on. Although the triangle was known to both the Chinese and the Arab cultures for several hundred years before, it was named after the person who brought it to the forefront of mathematics. French mathematician Blaise Pascal, 1623 to 1662. For more information about Pascal, see History of Mathematics.
What is computational ecology?
Computational ecology can be considered a subset of environmental modeling, because it addresses practical questions arising from environmental problems using mathematics. For example, in the field of ecotoxicology, mathematical models are used to predict the effects of environmental pollutants on populations. Natural resource management uses mathematics to set quotas for fish and game. And conservation ecologists use mathematical models to determine the effects of various recovery plans for threatened species, and even to design nature preserves.
What is the Heisenberg uncertainty principle?
German physicist Werner Karl Heisenberg, 1901 to 1976, not only helped with the quantum theory of light waves. He also developed the Heisenberg uncertainty principle. This states that it is impossible to determine, at the same time, both the energy and velocity of a particle.
They are listed as follows: n indicates natural numbers or integers, x represents real numbers. Z stands for complex numbers. What are some other terms used in dealing with algebraic equations?
There are many terms in algebra, including those dealing with equations. The following lists some of the more common ones. Equality and inequality. An equality is a mathematical statement that shows the equivalence of two quantities. For example, if A is equal to B, it is written as the equality A equals B. An inequality is just the opposite, A does not equal B, or A asterisk B. Formula. A formula is a rule, fact, or principle expressed in terms of mathematical symbols, including equations, equalities, identities, or inequalities. Note, the plural of formula in Latin is formulae, but it has become more readily accepted as formulas. Identity. An identity is a mathematical relationship equating one quantity to another that initially may appear to differ. It also means an equation that is always true, such as the Pythagorean theorem. For more about identities, see below.
What is algebra?
Depending on whether one is a student or professional mathematician. The word can mean either of the following, both of which are further described elsewhere in this chapter. School algebra is what mathematicians refer to as the algebra we learn in middle and high school and call arithmetic. But for most people, algebra means solving polynomial equations with one or more variables. The solutions to such equations are often obtained by the operations of addition, subtraction, multiplication, division, raising to a power, and extracting a root. For more information about all these operations, see Math Basics. This also includes determining the properties of functions and graphs. But mathematicians use the word algebra most often in reference to the abstract study of number systems and operations within them, such as groups, rings, and invariant theory. This is called abstract algebra.
What is a coefficient?
In an algebraic equation, a coefficient is simply a multiplicative factor. In the majority of cases, the coefficient is the numerical part, most often a constant, of the equation. Thus, it is called a numerical coefficient. For example, in 3x equals 6, the coefficient is 3, in dash 3x equals 6, the coefficient is minus 3. As the coefficient takes on the sign of the operation, terms such as xy may not appear to have a numerical coefficient. But it is a number that is not written, but assumed. Coefficients do not have to be just numbers. In the equation 5x3y, the coefficient of x3y is 5. But in addition, the coefficient of x is 5x2y, and the coefficient of y is 5x3. Coefficients are also seen in functions. For example, in the function f, x equals 2x, the 2 is the coefficient.
What are some examples in which probability is used?
There are thousands of examples in which probability is used. Some are familiar, and some originate from the seamier side of life. For example, everyone has played at coin tossing at one time or another. Although there is no such thing as an idealized coin as circular one of 0 thickness, most coin tosses use the coins available, with either side face up. Heads or tails, also phrased heads up/down or tails up/down. Thus, one can think of a coin as a two-sided die in lieu of the six-sided cubes we are all used to in a game of dice. If a coin is tossed with a good amount of spin, we can denote the two possible results as H for heads and T for tails. If we repeat the tosses n number of times, we obtain n, H, heads and n, T, tails. Thus, the fraction of n, H, /n and n, T, /n can be thought of as the chance probability to get a head or tail, respectively, P, H, and P, T. Are the most common notations that represent the probability to get heads and tails, respectively. If we toss the coin many times, the result should be close to 0.5. Of course. This means that if we bet on the chances of heads and tails, we will not be much of a winner if we play too many games, and we will have to have really good luck to win if we play fewer games. Chuck-a-Luck is a gambling game that has been played at many carnivals over the years. It involves a player who may bet on any one of the numbers 1 through 6. Based on 3 dice placed in a cage. If a selected number appears, the gambler gets paid even money, if one of the numbers comes up twice. The gambler gets paid 2 to 1, and if the desired number comes up 3 times, the gambler gets paid 3 to 1. But if the player worked it out, he or she would find that the game's expected odds are worse than for almost any other table game of chance. The game is sometimes used as a fundraiser for charity. But the odds of coming away with more money than originally put in are quite small. And they are even worse if someone has loaded the dice. Probability can also be associated with the violent game of chance called Russian roulette. In this bizarre sport, one or more of the 6 chambers of a revolver are filled with bullets. The magazine is rotated at random, and the gun is fired at the player's head. The risk-taker bets on whether or not the chamber that rotates into place will be loaded. If it is, he loses not only his bet but also his life. Not to be outdone, there are people who have come up with a modified version of Russian roulette. In this case, the gun is loaded with a single bullet and two duelists alternately spin the chamber. Each duelist fires at the other until one is killed. The probability of the first duelist being killed is 6/11.
What do the numbers on an aneroid barometer signify?
The non-liquid aneroid barometer measures air pressure. As the atmospheric pressure changes because of storm systems or lack of storms, the instrument records the changes. Because atmospheric pressure changes with distance above or below sea level. A barometer can also be used to measure altitude. The aneroid barometer contains a small capsule that acts like a bellows, but with the air removed. When the air pressure increases, the sides of the capsule are pushed in and the connected needle rises, moves clockwise. When the air pressure decreases or falls, the capsule's sides puff out and the needle moves in a counterclockwise direction. The numbers on a common barometer range from about 26 to 31. With divisions of 10 or more in between each number. A needle, actually a hand similar to a clock hand, points to the numbers on the barometer and moves in response to the changing air pressure. These numbers are based on the principle that atmospheric pressure supports 30 inches. 76.2 centimeters, of liquid mercury in a tube with one end sealed. And this information is based on the mercury barometer, the first type ever made.
What is logic?
Although it closely resembles mathematics, and is sometimes used as a basis for it. Logic is a branch of knowledge or inquiry that is separate from mathematics and the sciences. But it is still used by both fields in various ways. Simply put, logic is described as the systematic study of well-founded inference, in which there is a definite distinction between logical validity, also known as the formal properties of the inference process, and truth. This also means that a true result may come from an invalid argument. See below for the definition of an argument. For example, all cats are cute, Fluffer is a cat, therefore, Fluffer is cute. Is a valid inference, whereas, all cats are cute, Fluffer is cute, therefore. Fluffer is a cat, is an invalid inference, even if Fluffer really is a cat.
What is metamathematics?
Metamathematics is the study of mathematical reasoning in a general and abstract way. Usually by trying to understand how theorems are derived from axioms. Thus, it is often called proof theory. For more information about axioms, see below. It does not study the objects of a particular mathematical theory, but examines the mathematical theories themselves with respect to their logical structure. Metamathematics is also used in logic to study the combination and application of mathematical symbols. This is often referred to as metalogic.
What are the connections between logarithms and algebra?
Logarithms are the numbers of the power to which a base must be raised in order to get a given positive number. For example, the logarithm of 100 to the base 10 is 2, or log 10 100 equals 2. This is because 10 equals 100. Common logarithms are positive numbers that use the number 10 as the base. They are written as log x. Those using the number symbolized by e as the base are called natural logarithms. Also phrased as logarithms with a base e, the natural logarithm of a number x is written as ln x.
What is a system of equations?
System of equations is any set of simultaneous equations two or more that are intertwined and have to be determined together. They are usually a finite set of equations with the same unknowns, all of which have common solutions. A set of linear equations is said to be a linear system, while a set of homogeneous linear equations is called a homogeneous linear system. The number of equations is finite, meaning the solutions don't go on forever like some with billions of answers. But a word of caution, some problems use systems with hundreds of equations and just about the same number of variables.
What were some contributions John Haldane made to genetics?
Scottish geneticist John Burton Sanderson Haldane, 1892 to 1964, along with Sir Ronald Aylmer Fisher, 1890 to 1962, and Sewell Green Wright, 1889 to 1988, developed population genetics. Among other contributions, Haldane's famous book The Causes of Evolution, 1932, was the first major work of what came to be known as the modern evolutionary synthesis. It made use of Charles Darwin's theory of the evolution of species by natural selection, presented in terms of the mathematical consequences of Gregor Mendel's theory of genetics, to form the basis for biological inheritance.
What are identity and conditional equations?
Identity and conditional equations are ways in which numbers associate with each other. When an equation is true for every value of the variable, then the equation is called an identity equation. It is often denoted as I or E, the E is from the German Einheit, or unity. For example, 3x equals 3x is an identity equation, because x will always be the same number. 0 is the identity element for addition, because any number added to 0 does not change the value of any of the other numbers in the operation, or x plus 0 equals x. The number 1 is the identity element of multiplication. As any number in an operation multiplied by 1 does not change the value of that number. Multiplication identity is often written as x(1 equals x). When an equation is false for at least one value, it is called a conditional equation. For example, 6x equals 12 is conditional because it is false when x equals 3, and any number other than 2. In other words, if at least one value can be found in which the equation is false, or the right side is not equal to the left side, then the equation is called a conditional equation.
What is statistical quality control?
Quality control has been around for a while in a crude sense. When a certain product was manufactured, and consumers chose that product, the makers would try to improve the quality of the product or lower its price. The improvement of the quality did not stop with the product, but also included the process for making the product. But the use of mathematics was minor in early quality control. It was not until the 1920s that statistics was applied to industry and quality control. Mainly because of the development of sampling theory. For more about sampling, see Applied Mathematics. Modern statistical quality control refers to using statistical techniques for measuring and improving the quality of processes. It is often broken down into statistical process control, SPC, see above, and statistical quality control, SQC. Both terms are usually used interchangeably, although SQC has a broader focus than SPC. To compare, SPC is the application of statistical techniques to control a process, reducing variation so that performance remains within specific limits. SQC is the application of statistical techniques to control quality and includes acceptance sampling, inspection of a sample from a lot to decide whether to accept that lot, as well as SPC.
What did David Hilbert propose in 1900?
In 1900, German mathematician David Hilbert, 1862–1943, proposed 23 unsolved mathematical problems for the new century, most of which only proved to bring up other problems. By the 1920s, Hilbert gathered many mathematicians called the formalists to prove that mathematics was consistent. But all did not go well as mathematical complications set in. By 1931 Kurt Gödel's incompleteness theorem dashed any more efforts by the formalists by proving that mathematics is either inconsistent or incomplete. For more about Hilbert, see Foundations of Mathematics.
Have computers had an effect on the field of statistics?
Yes, computers have had a definite effect on the field of statistics. In particular, personal computers, software such as spreadsheets and professional statistical packages, and other information technologies are now an integral part of statistical data analysis. These tools have enabled statisticians to perform realistic statistical data analysis on large amounts of data faster and cheaper than ever before. Statistical software systems are most often used to determine examples, understand existing concepts in the statistics, and to find new trends in statistical data. Most of the packages allow the data to be entered into the computer program. But the emphasis then switches to the statistician's ability to interpret the data. There are two well-known programs often used in statistics: the SAS and SPSS, both of which are commercial statistical packages. The SAS system is a statistics, graphics, and data management software package available for personal computers. It allows the desktop computer user to get the quality of results once reserved for users of mainframe computers. The SPSS, statistical package for the social sciences, is also a popular software package for performing statistical analyses. It enables the user to summarize data, determine if there are significant differences between groups, examine relationships among all the variables, and even graph the results.
What are the ways credit card companies calculate finance charges?
When the credit card issuer calculates the finance charge on a card, it applies a periodic rate to a balance. In order to calculate that balance, the company uses various methods. The most common is the average daily balance method, in which the balance is calculated by taking the amount of debt in the account each day during a specific period and averaging it. The previous balance method uses the outstanding balance at the end of the period to compute the finance charges. The adjusted balance method derives the balance by subtracting any payments made during the cycle from the previous balance, with new purchases not being counted.
What is a solution?
When an equation has a variable, the number that replaces the unknown and makes the equation true is called a solution. For example, for the equation 5xy plus 2 equals 12, y would be 2. Or 2 is the solution that makes the equation true. To work this out, the process would look like this: 5x2 plus 2 equals 12, 10 plus 2 equals 12, and, finally, 12 equals 12. Remember, when finding a solution for an equation, one must follow any parentheses. Exponents, multiplications, divisions, additions, and subtractions in the correct order of operation.
What is linear algebra?
Linear algebra is the study of linear sets of equations. It encompasses their transformation properties and includes the analysis of rotations in space, least squares fitting, and numerous other problems in mathematics, physics, and engineering.
How is wind speed measured?
Wind speed is most often measured using an anemometer. The simplest ones are made with cup-shaped devices that spin and catch the winds. The number of spins translates into an approximate value for the wind speed. The more accurate electronic anemometer has a free-moving turbine suspended in the middle of the instrument that, when held correctly, measures the wind speed. The speed of the turbine sensed by an infrared light relays the signal to an electrical circuit. From there, the wind speed is digitally displayed.
How are vectors added?
One way to combine vectors is through addition, or composition. This can be done algebraically or graphically. For example, to add the two vectors u-3, 1, and v5, 2. One can add their corresponding components to find the resultant vector r2, 3. One also can graph u and v on a set of coordinate axes, completing the parallelogram formed with u and v as adjacent sides. Obtaining r as the diagonal from the common vertex of u and v.
How can functions be defined based on variables?
A function having a single variable is said to be univariate. With two variables, it is bivariate, and with more than two variables it is multivariate. Although two variables are considered multivariate by some people.
When was the calculating machine first mass-produced?
Between the 1624 invention of Blaise Pascal's calculating machine and 1820. There were about 25 manufacturers of such devices. Because there were so many, most had little funding and only one person. involved very few machines were actually manufactured in any quantity. By 1820 the first calculating machine to be commercially successful and produced in large numbers was the arithmometer. Invented by Frenchman Charles Xavier Thomas de Colmar, 1785 to 1870, while he was serving in the French army. It was based on a Leibniz step drum mechanism, see above. Colmar's machine used a simple system of counting gears and an automatic carry, automatically shifting a 1 to the left when the sum of a certain column was greater than 9. The technology of the times also helped catapult Colmar's success, because it included springs and other machinery that offset the momentum of moving parts. The arithmometer stopped at a specific, intended point, unlike what often happened with the older calculating machines. One of his first ventures into calculating machines was the difference engine, which was based on Johann Müller's design and some of Thomas de Colmar's arithmometer features. For more information about both, see above. The idea was sound, but the execution eventually lacked government funding. Not to mention suffering from disputes with the artisan who was making the parts for the machine. Not only that, but Babbage's ambitions may have caused the difference engine prototype to come to a halt. Initially, he wanted the device to go to 6 decimal places and a second-order difference. Then he began planning for 20 decimal places and a sixth-order difference. This much larger machine was an overwhelming concept for its time. The abandonment of the difference engine did not stop Babbage, however. Again approaching the government for funding, he promised to build what he called the analytical engine, an improved device capable of any mathematical operation, effectively making it a general-purpose, programmable computer that used punch cards for input. This new device would use a steam engine for power, and its gears would function like the beads of an abacus, with the main tasks of calculating and printing mathematical tables. For 8 years, he attempted to get more money from the government, but to no avail. He would never build his analytical engine.
What is the music of the spheres?
Not only was the Greek mathematician and philosopher Pythagoras of Samos, c. 582 c. 507 BCE, credited as the first to prove the Pythagorean theorem. He also discovered the music of the spheres. He found that the pitch of a musical note depends on the length of the string producing the sound, enabling him to develop intervals of the musical scale with simple numerical ratios. When a stringed instrument is played, if the musician puts pressure halfway along the string's length, he or she produces a note that is 1 octave above the string's note. In other words, the same quality of sound but at a higher pitch. Octaves increase by 1 step each time a string vibrates at twice the frequency of the previous note. This is expressed mathematically as a frequency ratio of 1:2, string octave. Pythagoras recognized other ratios, too, such as the perfect fifth. ratio 2:3, and the perfect fourth, 3:4, thus developing the mathematical basics of musical harmony. Pythagoras took music and mathematics a bit further. Believing that the musical octave was the simplest and most profound expression of the relationship between spirit and matter. For more about Pythagoras, see below and History of Mathematics. He also taught that each of the known planets produced a particular note, generated by its motion, according to the planet's distance from the Earth. Calling this musica mundana, or the music of the spheres, it was music no one could really hear. He and his followers, called the Pythagoreans, further used music to heal the body and to elevate the soul. Yet they believed earthly music was just a faint echo of the universal notes. Although today it may seem more magic than hard science and mathematics, maybe Pythagoras was right. After all, many researchers believe music does have the capacity to heal a person under certain circumstances.
When was a mechanical calculating device first used for the American census?
When government officials estimated that the 1890 census would have to handle the data from more than 62 million Americans, there was a slight panic. After all, the existing system was slow and expensive. Using tally marks in small squares on rolls of paper, which were then added together by hand. One estimate determined that such an endeavor would take about a decade to complete, which would be just in time to start the process all over again for the 1900 census. In desperation, a competition was set up to invent a device that could easily count the 1890 U.S. census. Thus, in the 1880s, American inventor Herman Hall Erith, 1860 to 1929, who is also known as the father of modern automatic computation, presented his competition-winning idea. He used jacquards punched cards to represent the population data. Then read and collated the information with an automatic machine. With his automatic tabulating machine, an automatic electrical tabulating device, Hollerith would put each individual's data on a card. With a large number of clock-like counters, he would then accumulate the results. From there, he would use switches so the operators could instruct the machine to examine each card based on a certain characteristic, such as marital status, number of children, profession, and so on. It became the first such machine to read, process, and store information. The machine's usefulness did not end there, though. Eventually, Hollerith's device became useful for a wide variety of statistical applications. Certain techniques used in the automatic tabulating machine were also significant, helping in the eventual development of the digital computer. Hollerith's company would also eventually become well known, becoming International Business Machines, or IBM, in 1924.